This is problem number 3 from section 7.5. It says use identities to find values of sine 2x and cosine 2x with the following condition. So again, we've got double angle here, sine 2x, cosine 2x. So we're going to be using double angle formulas, but the first thing we need to do is look at the conditions they give us. They tell us tan x is 4, but they tell us cosine is less than 0. So we need to figure out what quadrant we're in, draw a triangle. Let's not just find tan x, we need to find what sine x and cosine x is. So let's draw coordinate plane. This is quadrant 1, 2, 3, 4. It says tangent is equal to 4, which is positive. We know tangent is positive in quadrants 1 and 3. Because remember, tangent's sine over cosine. So both sine and cosine have to either be positive or they have to be both negative in order for this to work. Cosine is less than 0, quadrant 3 or quadrant 2. What do they share? They share quadrant 3, so that is where we're located, quadrant 3. So we can go ahead and draw another coordinate plane, this time drawing a triangle for that area. And they say tangent, remember this is our x value here because you're using x not theta. So tangent x is 4, meaning this side is, which is opposite, is 4. This side is 1 because opposite over adjacent, right? 4 over 1. Now, the 1, though, we know is negative. And we also know the 4 is negative. Because we're in quadrant 3, right? Negative x value, negative y value. So what is this value here for the hypotenuse? Well, we'd say negative 1 squared plus negative 4 squared equals the whatever the side length is, and we'll call that, just for this problem, we'll call it the hypotenuse squared. So that's 1 plus 16, which is equal to h squared. So that's 17 equals h squared. So h equals root 17. So that's the hypotenuse. So if tangent is 4, we now know cosine, so we'll write that tangent x is 4. We know cosine x is negative 1 over root 17. And sine x is negative 4 over root 17. Okay. So now we know those the three functions we need. We can start to use our double angle formulas. Sine 2 theta, they want sine 2x. Sine 2 theta is just replacing theta with x, same idea. So we're going to say that sine 2x is equal to 2 times sine x. Sine x is negative 4 over root 17. And cosine x, which is negative 1 over root 17. Now this is pretty easy to evaluate because of the roots. So we can do this by hand. 2 times negative 4 is negative 8. Times negative 1 is 8. And then root 17 times root 17 is, well, the roots cancel and we get 17. So that's one of our answers. If we do cosine 2x, cosine 2x, again, I usually like to use this 2 cosine squared minus 1. I think we can do that. Let's go 2 times cosine x, so negative 1 over root 17, and we're squaring that, minus 1. That's going to give you, when I square the inside here, I get 2 times, that negative 1 squared is 1, and root 17 squared just cancels that, so that's 17, cancels the root, minus 1. So we end up with 2 over 17 minus 1, which if we make this into a common denominator, we end up with 2 over 17 minus 17 over 17, which is negative 15 over 17. And those are our solutions for sine 2x and cosine 2x. And again, we used, really the hardest part of this whole thing is figuring out the quadrants and then figuring out our cosine x and sine x. Once we find the three functions, we can use the double angle formulas pretty easily.